And welcome back. As we go ahead and continue looking at different aspects of classes, let's today discuss the null keyword. So when we're talking about null, what are we exactly referring to? Well, the constant null is actually a very special constant that can be assigned to a variable of any class type. This means whether it's a string class, a date class, whatever, we can give it this null value. Null is simply just a way for us to indicate in our code that a variable has no real value. There's nothing assigned to it. Doesn't mean that it's zero or it has nothing really. It's just has nothing in it. So we don't have, for example, any strings or integers or other class types that are assigned to it. Now, if the compiler, for example, says though you have to initialize a variable of a class type, and there's no suitable object for which you want to initialize it to. So let's just say we have a class type called a class. And I say a class, a object equals new, blah, blah, blah. That would be normally how we do it. However, if we don't know what that is, we can initialize it with the value null, such as the following example. Your class, your object equals null. And that will satisfy the compiler so you won't get an error. Now, obviously, this does lead to some potential issues, but just to get that object in there, just like if I were to say like int num, I don't have to assign it a value right away. I eventually will want to assign it a value, but we can do the same thing here with class objects by saying equals null, and that's the same thing as if we had like a primitive type, say like int num again. We can do that here with null. So let's look at how null can factor into our constructors then. It's common to use the null object in constructors to initialize instant variables of a class type when there's no obvious object use. And of course, we'll eventually see other uses for that constant as well. So one thing we do want to note though, first off, is that null is not an object. It is not a string. It is not a date. It is not my class. It is simply its own keyword. The best way to think about null is that it is a reference or a memory address that doesn't refer to any object or in fact doesn't name any memory location. You're not pointing to any spot in your memory for this. So if you want to test whether a class variable contains null, you actually can use equals equals or not equals. You're actually not going to use the equals method because again, remember, it doesn't have a location memory, and because we're not looking at location memory, we use the equals equals or not equals to see if that is the case. So if we want to see that with some code, let's say if your object equals null, so print line, no real object here. That's a way for us to test to see if something is null. Now there is some pitfalls that we have to avoid here, which is the null pointer exception. This is a very common one that we can run into. If the compiler asks you to initialize a class variable, we can always initialize it to null. However, because null is not an object, you cannot invoke a method using a variable that has been initialized to null. So if we go back to that previous example with your object, if I try to use, for example, a method that would belong to that class, we would have problems because it's not going to have a value for it to pass into that method. So when this happens, what we get is an error message and it'll say null pointer exception. So for example, the following code would produce a null pointer exception if we're including a program. If we say a toy class of variable is null and say string representation equals a variable dot toString. Well, dot toString is a method that would exist in that toy class 2. However, because we have toy class 2 a variable set equal to null, we are going to have an issue because null, remember, doesn't represent anything. And because it doesn't represent anything, when you try to write it out to a toString, it doesn't know what you want. So the problem is, again, when we look at, for example, toString, toString is trying to use null as a calling object. But as we already mentioned, null is not an object. It's simply just a placeholder. So because it's a placeholder, it doesn't have access to any of those methods that are in the class. And because we are actually using null incorrectly in this example, the error message would read null pointer exception. Now this, of course, is just one example with toString, but you can get this error message anytime a class variable has not been assigned a reference to an object, even if you have not necessarily assigned null to the variable. Anytime you get null pointer exception, just look for an uninitialized class variable. So it has to be like set equal to like a new instance of something. So of course, the best way is always to create first a new class object, as we've been doing, and as we see here in the example, toy class 2, a variable equals new toy class 2. that allows us to initialize that into a variable. If I had left that as equals null, then of course we get that error. Now, if we go ahead and take a look at this with some code, of course, our toy class 2, you can see has a couple of different methods in here that are available to us. But the thing I want to focus on is in the demo here. So here we have toy class 2 equals new toy class, and then we have object 2 equals new toy class, and of course we're setting those and calling them. And if I just go ahead and run this, it should of course function pretty easily. Now, one thing I do want to show, and I'm just going to go ahead and add in here some code just so that we can see this. So toy class 2. And I'm just going to change this to a semicolon. Let's just go ahead and change object 1 to null, just so you can see what's going to happen when I try to do this. Now, you notice there's a warning here. It says a null pointer access. The variable can only be null location. This is a hint that says something might not be right. Now, it doesn't necessarily cause an error at this point because there could be things later on that will change that. But if I go ahead and try to run this code, immediately you see we get a null pointer exception. It says cannot invoke the set method because object 1 is null. And that, of course, caused us to have this issue. If we had the original new toy class 2 object, then of course we would run perfectly fine. Now, if you do have something like this and you say, you know, I wanted to start as null, how do I change it later? Well, all I need to do is take object 1 and set it equal to a new toy class 2 object. Again, that'll take care of that warning. You see it's gone now. And so now if I run it, our code executes just fine. And the reason for that is because we have overridden this value of null. So anytime you use null, it's perfectly fine to give us that initial value. In fact, you might see that, for example, we look at constructors. You might see if we had a toy class 2 constructor down here, instead of saying name equals this, number equals this, if we had set these to null, that would have been fine, but then of course we would have to make sure we eventually give them some value. And here, by setting this to null, it doesn't cause issues, but if we try to invoke it with those methods, that's where we run into issues. So we have to make sure we set it equal to a new instance of an object in order to properly handle those methods we want to execute.